Welcome to section 12.3, the surface area of circular solids. We're going to find the surface area of cylinders, cones, and spheres. For our homework, it's on page 572 to 573, 1 to 13. First in this section, we have to address our vocab words. First and foremost, a cylinder. A cylinder is a polyhedra with two parallel circular bases. A cone is a polyhedra with one circular base. A sphere is a circular polyhedra with no bases. Now, a lateral area formula is associated with this. First, for a cylinder, the lateral area of a cylinder is going to be the perimeter of the base times the height of the cylinder. This formula is going to be exactly the same as a prism. Next, a cone is going to be 1/2 the perimeter times the slant height. This formula is going to apply to all cones. And last but not least, a sphere. A sphere has no lateral area because it has no bases. Next, our surface area formulas. The surface area of a cylinder is going to be the lateral area plus 2 times the area of the base. For a cone, it's the lateral area plus the area of the one base. And for a sphere, it's 4 times pi times radius squared. And now let's start solving some of these. First and foremost, we're going to find the lateral area and surface area of this cylinder. So lateral area. We're going to take the perimeter of the base, and perimeter of a circle is circumference. 2 times the radius times pi times the height, 10. 12 pi times 10 is going to be 120 pi for our lateral area. Now our surface area. The surface area takes the lateral area, 120 pi, plus 2 times the area of the base. Area of a circle is radius squared pi. So 120 pi plus 2 times 36 pi gives me 120 pi plus 72 pi, which is 192 pi. Next, let's find the lateral area and surface area of this cone. For our lateral area, we have 1/2 the perimeter of the base, again 2 times the radius, or a diameter, 16, times pi, times the slant height. And we have a problem here. We don't have my slant height. Well, we know this height is going to be hitting our cone smack dab in the middle, splitting it into equal pieces, 8 and 8, and forming a right angle where it hits. We're going to use Pythagorean's theorem. 8 squared plus 15 squared equals x squared. And when I solve using Pythagorean's theorem, x equals 17. 17 is my slant height. Half of 16 pi is going to be 8 pi. And 8 pi times 17 is going to end up giving me 136 pi. Next, we have to find our surface area. To find our surface area, we need to take that lateral area, that 136 pi, and add on the area of my base, radius squared pi, 64 pi. When we add that up, we end up with a total surface area of 200 pi. Our next example, let's find the surface area of the sphere. Now, the distance from the top to the bottom is actually going to be the diameter of our sphere. What we need here is we need to find our radius. Our radius is just going to be half, so 6. And let's plug it into our formula. 4 times pi times radius squared gives me 4 pi times 36. And 4 times 36 is going to be 144 pi. Now, we're going to get a little bit trickier on this next one. I want us to find the surface area of this hemisphere, a half of a sphere. Now, think about what surface area means. It means it's going to cover all the surfaces. So we have that rounded half of a sphere. But now, where we didn't have a base before, we have a base. It's a base we can touch because it is the hemisphere. So here's what we're going to need to do. We're going to need to take that hemisphere, or that half sphere, find its area, and then add on the area of the one base. So the hemisphere. Instead of 4 pi radius squared, we have 2 pi radius squared, which gives me 2 pi times 121, which is going to give me 242 pi. Now, the area of my base. It's a circle base, so radius squared pi, which is 121 pi. And when I go ahead and I add that on, 242 pi plus 121 pi is going to end up giving me 363 pi for the total surface area, all the touchable surfaces. So here's a word problem. The surface area of a sphere is 72 pi. Find the length of the radius. Press pause and let's see what you can do. Well, here we go. We know our surface area formula is the surface area is going to equal 4 times pi times radius squared. So 72 pi equals 4 pi radius squared, and let's divide both sides by 4 pi. Those pi's are going to end up canceling out. And when I go ahead to reduce that, 72 divided by 4 is going to end up giving me 18 equals my radius squared. Go ahead and square root that and simplify. It's 9 times 2, which simplifies to give me a radius of 3 square root 2. So here's another word problem. We're going to find that an ice cube manufacturer makes ice cubes with holes in them. Each cube is 6 centimeters on a side and the hole is 4 centimeters in diameter. Find the surface area of the ice cube. Now, let's first start off by drawing a good picture and then see if we can come up with a game plan. So first and foremost, we have a cube, which is made up of squares. So here's my cube, and it has a hole in the center. Now, the cube is going to be 6 centimeters on each side. So 6 for my width, 6 for my length, 6 for my height, and the diameter of that hole is going to be 4. Now, surface area refers to all touchable surfaces that we have. Now, what we have here is we have the surface area of a cube. We have to take out this hole. The hole is actually circles that happen on 2 sides of my cube. Now, when that hole passes through, it actually creates another surface that we can touch. It creates that inner surface, which is actually the lateral area of my cylinder. So here's my game plan. We're going to find the surface area of the cube. We need to take out those 2 circles, which is where our hole was formed. And then we need to add in the lateral area of the cylinder. So here we go. The surface area starts off with the lateral area, the perimeter of the base times the height of the prism, which gives me 144. Then we need to add on 2 times the area of my base, which gives me 144, plus 2 times 36, which is 72, which is going to end up giving me 216 for the surface area of my cube. Now each hole is radius squared pi. If the diameter is 4, that means that the radius is going to be 2. So 2 times 2 squared pi is going to give me 2 times 4 pi, which is going to be 8 pi. But then I need to add on the lateral area of the cylinder, which is going to be the perimeter of the base, or the circumference, which is 2 times the radius times pi. 2 times the radius times pi, times the height. And the height is going to match with my cube, which is going to be 6. 4 pi times 6 is 24 pi. Combine my like terms, and my final answer is going to be 216 plus 16 pi for a total surface area. So here's my last example. We're going to find the surface area of this polyhedra, which is not a cylinder, it's not a cone, and it's not a sphere. But what I do see is I have slanty sides right here. Now, if I was to extend those slanty sides, I would eventually make a cone, in which case I can find the surface area of that big cone. But I wouldn't need this top piece right here. Now the surface area would cover this rounded part plus my base. I don't need this rounded part up here, which would just be the lateral area of my small cone. But then I would need to include the circle part, which is actually the top of my original. So I'd want to add in that small circle. So here we go. Surface area of the big cone is 1/2 the perimeter, which would be 2 times the radius, so 12, times pi, times my slant height, and I have my first problem. I don't have a slant height because I'm missing this piece up here. Now, the radius of my big circle is 6. My small circle is 3, and where it meets is 0, which means that this 3 is actually my midline, which would bisect my base, making a side 5. Which means that the slant height of my big cone is actually 10. The slant height of my small cone would be 5. So 1/2 perimeter times slant height, half of 12 is 6, and 6 times 10 is going to be 60 pi. I need to add on the area of my base. The area of my base is radius squared pi. So 60 pi plus 36 pi is 96 pi. Now I need to take out the lateral area of my small cone. 1/2 the perimeter, 2 times the radius, so 6, times pi, times the slant height 5. Half of 6 pi is 3 pi, and 3 pi times 5 is 15 pi. Last but not least, I need to add on the area of that small circle. That small circle is radius squared pi, which is going to give me 9 pi. So here we go. 96 pi minus 15 pi plus 9 pi is going to give me a total of 102 pi. So here's the answers to our homework. Again, it was in section 12.3, numbers 1 through 13. If you have any questions, please make sure to ask, and as always, have a good one.